In this video, we show the Physicist Hermite polynomials using the functions FACTDOUBLE, SERIESSUM, and LINEST. We begin with the values of n, where n is from data validation over the range 0 to 10. And save. So our value for n starts from 0 up to 10. And the formula of the Physicist Hermite polynomial, which is the summation of this coefficient, which is negative 1 raised to the power k n factorial times double factorial 2n minus 4k divided by factorial k times factorial n minus 2k times x raised to the power n minus 2k, where the value of k is from 0 to 0.5n. So this would be equal to sequence 0.5 times n plus 1, start one column starting from 0 incremented by 1. So if it is, let's say 6, then it's 3. If this is 3, then it is 1. And the coefficients, which is array formula, minus 1 raised to the power k. That's the first part of the numerator. The second part is factorial n times, this is double factorial 2 times n minus 4k. We have completed the numerator. Now the denominator. The denominator has two parts, factorial k. Second part is, this is factorial n minus 2k squared. So factorial n minus 2k. And this factorial is raised to the power 2. That's squared. And enter. So if this is 10, this should be empty. So we correct this. So if this is empty, then 0, otherwise calculate. Now it's corrected. Now we can complete the expansion, which is the summation of SERIESSUM. So this is array formula, SERIESSUM of the x values raised to the power 2n minus or n minus 2k. So it will start from n incremented by 2k, which is minus 2. And the coefficient will be this range. And we'll chart this. And we use scatter chart. Show the trend line. Under series, you show the trend line. The type polynomial. The degree 10th. And for the label, use the equation. And for the legend, position at the bottom. Here's our trend line and the polynomial. So we'll calculate this polynomial regression coefficients. We don't need the title, we need a space, so we delete this. We continue. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix. So array formula of the x values raised to the power 0 to 10. Now we can use LINEST. This will be LINEST data y and data x. we have the polynomials. Let's start with the value of n equals 0. At n equals 0, it is x. N equals 1, it will be 2x. That's 2x. N equals 2. That's minus 2 plus 4x squared. Minus 2 plus 4x squared. N equals 3. That's minus 12x plus 8x cubed. Minus 12x plus 8x cubed. N equals 4. That's 12 minus 48x squared plus 16x to the 4th. 12 minus 48x squared plus 16x to the 4th. N equals 5. That's 120x minus 160x cubed plus 32x to the 5th. So 120x minus 160x cubed plus 32x to the 5th. N equals 6. So minus 120 plus 70x squared minus 480x to the 4th plus 64x to the 6th. So minus 120 plus 720x squared minus 480x to the 4th, 64x to the 6th. N equals 7. Minus 1680x, 3360x cubed, minus 1344x to the 5th, 120x to the 7th. So minus 160x, 330x cubed, minus 1344x to the 5th, 128x to the 7th. And then x to the 8th, or n equals 8, 8 degree. 1680 minus 13,440x squared, 13,440x to the 4th, minus 3,580x to 84x to the 6th, 256x to the 8th. That's 1680 minus 13,440x squared, 13,440x to the 4th, minus 3584x to the 6th, 256x to the 8th. And n equals 9, the 9th degree. So 30,240x minus 80,640x cubed, 48,384x to the 5th, minus 9,216x to the 7th, 512x to the 9th. So 30,240x, that's minus 80,640x cubed, 48,384x to the 5th, minus 9,216x to the 7th, 512x to the 9th. N equals 10. So minus 30,240 plus 30,240, 302,400x squared minus 403,200x to the 4th, 161,280 x to the 6th, 23,040 x to the 8th, 1024 x to the 10th. This completes the use of Hermite polynomials, Physicist using FACTDOUBLE, SERIESSUM, LINEST.